Okay, good day to each and everyone. Today we'll be dealing with stocks and queues. To start with, what is a linear data structure? In linear data structure, data is arranged in linear sequence. Data items can be traversed in a single run. In linear data structure, elements are accessed or placed in contiguous memory location. So just like what we have discussed before, which is a linked list. Now, for the first one, what is stock? A stock is called a last in, first out collection. This means that the last thing we added is push, is the first thing that gets pulled, pop off. That's what we meant by LIFO. A stock is sequence of items that are accessible at only one end of the sequence. So the adding and the pop of the item will be only done in one end. So an example of stock is usually piles of books or plates. Okay. So in which we have the top. Okay. The operations that can be performed on stock is using push and pop, in which from the top most of the stock that we can only perform pushing and popping of an item. So which is the last entry, is where we'll be adding an item or data. Push, it is used to insert items into the stock, and pop, it is used to delete items from the stock, which is top, it represent the current location of data in stock. For the first column, we have here the current content is CBD, in which C is the top item on the stock, in which if we have push D, there will be another or additional data which should be added on the top of the stock. And we have push E again, so will be added on the top. And now if we pop, we also start deleting the items on the top of the stock, which is D, and another command which pop. So of course we'll be deleting another stock out the top of the stock. Okay, so all pushing and popping is done only at one end. Okay, so we have here the last entry a while ago is E, and then if we pop, is the last entry. It's what we call the last input. And then when we have pop it, the item that was popped was E, in which is on the top of the stocks. Okay, so for the next slide, it's algorithm and inserting the pop from the item. Okay, so we here is certain command in which on how we'll be pushing the stocks on the data. So how do we push an information on the stock? Okay, now when you say algorithm is only series of steps or procedure, no, it's not actually the code. Now the first item was, we have here if top max, so we have a certain particular size of the stock that we have declared in our code. So let's say for instance only 10 items or 10 data that can be handled by our stock, or 20 is for us. Now if our top will be equivalent to that particular number or your maximum assigned size of the stock, will be having a message of stock overflow. It means that we already come up with the highest number of data that we'll be putting in our stock. Now, if it is not reach the maximum number of our stock, that's the time that we'll be adding top plus 1. So for instance, the initial value of top would be 0 plus 1, or let's say 5. No, top is 5, then plus 1, so we'll be adding the data on 6. That, as we have here in our screen or the figure, so the current content of the stock is CBA, which is 3. So our top would be 3, and then we'll be adding plus 1. So the item D will be pushed on 4. Okay, so a top item will be number 4. So that will be the storage of the data item D, in which what we have pushed. Okay, for the algorithm for the deletion, so as we have the same thing with we have the pushing. So when we delete on the stock by using the pop command, so the first thing is on the algorithm is just see to it if the stock is empty or there's no content of the stock. If your top is equivalent 0, it means that there's no certain value among the stock. Okay, now for the entry, that if we have popped it, so we have to come up what is the value of our top stock. Okay, as we have here currently, so we have 4 stock initially. So when we have pop it, so we'll be popping 15, and then if we have pop again, we'll be popping 12, and then another pop, so we'll be popping 10. So hierarchically we'll be deleting from the topmost going to the lowest most value on the top stock. Okay, so that for the deletion, so it's the same thing. So the accession of the data will always on the top or one end. Okay, so that's the nature of the algorithm or the stock data. Okay, now for displaying of the stock, so usually when we have access the information over the stock, it always start from the top, so we'll be easily reversing the information that we have entered. Okay, so for instance, we have here, we push a while ago or before that we have push R, EB, in which in terms it is a reverse. No, now if we display this content of this stock, will be immediately in reverse order, because the first displaying of this stock will start from also from the top. So he will be printing initially for print of A of I will start from the top. Okay, so that's I equal to top, which means 1, 2, 3, 4, 5, 6, 7. So we'll start from 7 down to 0, or I should say 6. I should say it's because we stock also start from a 0 value or index, I should say. So A of I will start from 6, then A of 5, A of 4, so downward until we reach the A of 0, which is R. Okay, so that's how we display the content of the stocks. Now, how do we use the application for the stock? So there are a lot of application in which visually we do not notice that we are using already the stocks. So we have here convert infix expression to fast-fix and prefix expression. That was included in our module, or this is the only example in our module. But also we have also evaluate the postfix expression. Then we also have a reverse string, so it's easily to reverse a string. For instance, you could reverse any word just like your name into a reverse order. And then we have also check well form nested parentheses. So how do we use this one? So usually in terms of algebraic expression. So when you say check, So we'll be dealing with the number of open and close parentheses. Simulate recursion. So in the previous chapter of our class, we have already discussed recursion, in which repeatedly calling it's the same function, no, or what we have here, recursion, we can simulate it using a stack. Every output will be stored in a stack. And also, if you have remember your conversion of decimal to any other number system like binary or octal or hexadecimal, application of stack, using stack could be a great help, no, having a coding for the conversion of number, no, decimal to other number system. So we'll have several example of this, like postfix expression, parentheses, and this conversion. I will show it to you later on. Now first is we have here the parentheses checking, one of the application of the stack, in which declare a character stack S if the current, so we'll be dealing with certain algebraic expression that compose of bracket, curly bracket, or also parentheses, if it is balanced or not, no. So we have here checking if the character is a bracket, okay, or stacks, no. And if the current is closing bracket, then pop from the stack. If the pop character is the matching starting bracket, then find else parentheses are not balanced. So it will say if it is balanced or not balanced, or it could be valid or not a valid algebraic expression. So let's have an example of it. So we have here the example. So we have A, also that's the entire algebraic expression. So out here the figure, kindly watch this one. So if we undergo the running of the stack, so we have here a push a square or square bracket, which is the first character there, okay, so that we will be pushing it on the stack. So that's the current content now of the stack. Now again we push again, open parenthesis, this one. So the current content of the stack now is 2. So the square bracket and the open parenthesis. Then based from the algebraic expression, the next symbol for the parenthesis was a close parenthesis. Now from the previous content of our stack, you already have a pair of it, and use this one, okay. So we have now to pop it. So we can now pop the open parenthesis a while ago, okay. This way, I just have a laser pointer here, okay. So this now will be pop because it's already content or equivalent of closing of this one. So the content of our stack will now become a single character in which open parenthesis was being popped, okay. So based from now the next, so as we have noticed, I mark it light color, in which that's already been the matching, no, parentheses. Now the next pushing is the open curly bracket, which is pushed again to the stack, okay. So there are now 2 characters among the stack, and then the next character that you can push is another parenthesis, okay, there. So the content of the stack now is 3 items or 3 character. Now the next character among the braces or brackets is open close parenthesis, which matches. So if it is matched based from the rules that we have come up a while ago, is it will be popped on the stack. So Previously it was 3 content of the stock. Now it is matched on the next character, so it will be pop again, and their only remaining character will be 2, and the next character is close curly bracket. Now again it will now be pop again, because curly bracket is also a pair of this one, and when it's pop, we have only one close square bracket. Now the next character is there finally. So if we count the number of open bracket or open parentheses or open curly bracket, it matches from the algebraic expression. So if you could also notice when you're using Microsoft Excel and entering an equation, that's actually using of the stock, so it matches the number of open parentheses or curly bracket that you will be using should be matched entirely on the entire equation. So but of course for Excel we can only use only parentheses. It doesn't entertain open curly bracket and square bracket. Okay, but that's the purpose, one of the purpose of a stock, for parentheses. Okay, now for the next one, so evaluating arithmetic expressions. So we could have here infix notation. Okay, from a general way of writing arithmetic expressions known as infix notation. As human being, this is what we have able to come up to solve a certain solution. Now for a certain infix notation, we could also have a prefix notation. Prefix means so the variables, and we'll start from operators. So if we have postfix, after those variables, or the numerical values will be having operators at the end of the notation. Okay, so let's have also another example here, converting an infix into postfix. Okay, so we have here the equation is 2 plus open parenthesis 4, that's 1, close parenthesis asterisk or multiplied by 3 into, so there should be a result. This should be a result, which is 2, 4, 1 minus 3 times or asterisk and then plus. So this is a postfix because the higher operators are in the end of the notation. Okay, so for our current symbol, so we have here 2, then that will be forwarded on the postfix expression, which is 2, and then we have here the action performed is push plus. If we have here now pushing on the stocks, which is the first item, which is plus, and the same, the postfix expression will be remain 2. Now the next thing that we have to push now, actually this current symbol came from this one. Okay, so you have here 2 plus open parentheses 4. I hope you would notice it. Okay, so this one downward. Okay, so this came from here. Okay, from left to right, and it was arranged from top to bottom. Okay, so 2 plus open parenthesis, that's it. Okay, hope you get it. Okay, now let's go back from what we have here. Okay, so push plus, so there we have here the stock. Now we'll be pushing again open parenthesis, so the content of the stock now is 2 items plus sign open parenthesis. Now we have here 4, which is not an operator. Okay, So you just move on the postfix expression. So if you would notice, I mark it colorful 4. Okay, there are red. Those red are the changes made on the stock status and postfix expression. Okay. Now we have here negative or minus is push on the stock. So the current content of the stock now is plus, open parenthesis, and minus. Postfix expression does not have any changes at all. Now we have here 1 again, forwarded on the postfix expression. So that's why we have here 241. Close parentheses. Now, at this stage, when we have close parentheses, now the operators inside, so the previous content of the stock was plus, open parenthesis, then minus. Now we have here a close parenthesis that being pop. Okay, so it means we'll be popping negative. This one, the content of the stock is negative on the top, right? So that's why pop minus, okay, and it will be forwarded on the postfix expression. So it means this one will be goes to the postfix expression, okay. The minus goes to here, okay, and then parenthesis will be pop, okay. Both open and close parenthesis will be pop. So all what left is on the stock status now is only a plus symbol, okay. Now for the next thing is we have here push asterisk. So there will be a additional value on the stock, which is plus and asterisk. And then we have here 3 goes again to the postfix expression. Now there's no more character on the equation, so we are through with the symbols. Now popping 3 asterisk, I should say, it was the topmost of the stock status. Excuse. Okay, so it will goes on the postfix expression right beside with 3, and then again pop plus again will be goes with the post expression plus. Okay. Okay, for the conversion of infix to postfix conversion, so a while ago we have converted the infix to postfix. Now for evaluation of the output, so we have a while ago obtained 241 minus 3 asterisk then plus. So when we evaluate it, so we have here the first step was push 2, push 4, and 1. So that's the first numbers of our postfix conversion. Right after 1 is a operator which is a subtraction, in which we'll be subtracting the last 2 content of the stock, which is 4 and 1, which is 4 minus 1 would be equivalent to 3, and pushes them again to our stock, which is now the current content of the stock now will be 3 and 2. So right after the character or operator subtraction, we have here 3, in which that will be the next step, which is push 3, okay, here, and then the current content of this stock now will be 3, 3, 2, okay, so from the top. Now after 3, we have here a multiplication, which is asterisk. So it means that again, from the current content of our stock, we'll be multiplying the last 2 content of the stock, which is 3 and 3, by an operator of asterisk, which is a multiplication. So therefore that is 3 times 3 equivalent to 9. That would be now forwarded again to the stock, which we have the current content of the stock is 9 and 2. And the last operator was here is we have here plus. and then we have only last two content of the stock, which is 9 and 2. So we'll be using the plus operation or addition. So we have here 9 plus 2 will be equivalent to 11. So the result of the post-peak conversion using the stocks, which is also 11. Okay, so let's proceed with the next one. So that's the procedures that we have done a while ago, no? So when we have the character, and if you have this an operand push X into the stack S. Now if it is an operator, pop elements with perform operation and push result into stack. So that is what we have done a while ago, no? And if it is X is null, pop stack and print result. So what we have a while ago, checking. So the first we have the first operand was 214, I think, no? So let's no previously 241, I should say, no? That's the first that we have put on the stack. Okay, so that's the operand push X into the stacks. And after that we have obtain operator of a subtraction first. So we subtract 4 and 1 a while ago, and after that we push another operand, which is 3, and then after that another operator is asterisk, in which we have multiplied 3 and 3 and push the result again into the stack. And after we have multiplied 3 and 3, which is 9, so plus 2, we have another operator. So we add the last two content of the stack and popping that 11 and printing that result on our information for printing. Okay, that's for the evaluation of post-peak expression. We have another example here. Okay, so let's say we have here AB times C plus. So this is the post-peak expression. So we'll have a substitution here. A equal to 2, B equal to 3, and C equal to 5. So the first element is A and B. We push that both on the stack. So we have here A and B. The next is we have here asterisk. So it means that we multiply the first two terms A and B. Okay, which is A and B is 2 and 3. So if we multiply it, it will give us 6. And then we'll now pop A and B. What we have obtained is now we push now the result, which is 6. So what we have now here, the next item is C, in which C now will be pushed again to the stack, which C is equivalent to 5. After C we have here plus. So we'll be adding 6 and C, which is C is equivalent to 5. That is also 11. So when we add 5 and 11, we obtain 11 as our result, and that will be pushing on the stack, and we can now pop C and the result of 6. Okay, so that's another example of our evaluation for the post-peaks. Okay, certainly same output, which is 11. The last is we have here example conversion to decimal to other number system. If you have remember your introduction to computer, having this a lot of division or conversion of decimal to binary, binary to octal, and hexadecimal. So it was done repeatedly, and the corresponding remainders are pushed into the stack in order for us to obtain the converted value. So if we could remember, so if it is binary, so we have here an example, we just divided by 2. Okay, so for instance, we have here 84, we divide by 2, that's 42, and the remainder is 0. 42 again divided by 2 is 21, the remainder is 0. And 21 divided by 2 is 10, remainder of 1. So we do that until we have reached 1, no, or 0, no, and we obtain all the remainder as well as with octal and hexa. So we just have different divisor. For binary we use 2 because to the base of 2. For octal we divide by 8 to the base of 8, and 16 for hexadecimal. And all of them we are obtaining the remainder reversely. Okay, so stack is very helpful for converting this one. So from the topmost, so we will put that on the bottom or the first. Of course, when you divide a certain numerical value, the highest number will be on the first item of your stock and going upward. Okay, and then when you display it, of course we have to display it from the top in order to give us the right or exact conversion of the variable or numerical 84. So you could also use this one as the output of our stock. Okay, hopefully I could expect some will submit. No. Now finally, so we have here Qs is only a reverse of what we have discussed a while ago, which is on stock. Instead of LIFO, this is FIFO. So first in, first out. So in which the stock are used for reversing strings. So what we have also a while ago, used for undo, redo. Okay, we could also have a conversion of numbers, no? So later on we will have to able to know what are the advantage also of Qs in real world. Okay, let's go with the Q operation. Placing an item in Q is called insertion or NQ, which is done at the end of the Q called rear. Okay, so for Q operation meron tayong rear and front. Okay, so unlike on the stock, we just merely operate on the other end of the stock or the item. Okay, so for the Q operation, removing an item also. So a while ago we have the NQ. Now the Q, which is done at the front other end of the Q called front. Okay, so when we add, we go with the rear one. Now if we delete, we go with the front one. Okay, now for inserting, so we have here from the rear. Rear is the back. Okay, so we deduct it by 1. Let's say that's 4 minus 1. So we will say it that it's already overflow. Q is overflow. Now if it is not, we can still insert an item for our Q. Let's say we'll be having Q for cash payment, or just like bank also they have what we call Q number, right? So you just look onto your number if you are near about going on the bank, so what number you are in. So for deleting the algorithm also, of course we cannot delete a item which if our Q is empty. Okay, now if our Q is not empty, therefore we'll be having front plus 1, so we can now remove that particular item. No, so what comes in the first place and then, or the first in, she will be the first to be deleted. That's with the algorithm of the Q. For the Q applications, real life examples like waiting in line, like in banks, of course, or even in our school, paying your tuition fee before, if you are paying your tuition fee before, because nowadays we don't have any more tuition fees to be paid on our university. So we could also have round robin scheduling, job scheduling, and keyboard buffer. There are some of the application of Q. Also for printing, of course, if you are try to encounter using printer over the network. Of course, the first one we have issue or render an action for printing. That will be the first to be printed on our printer. Okay, so that is what we call it, first in, first out. Okay, so that will be all. Thank you very much.